I think I'm going to get started. That what we're looking for generally is the octet rule, which I mentioned in the other paper. Oh, by the way, and I posted this, I made a video about the end of the simulations that I think should really help. I don't know how many people watched it, but I did make one and I posted it. So the octet rule is not exactly a rule, but that's what people say. And we're looking that atoms want 8 electrons, except H only wants 2 electrons. Anish, I already got started. We're going to want to, I would think you'd want to print this out. I mean, you don't have to, but it would help. And you're going to want a periodic table.
Okay, thank you.
I already started the notes at the top. So, and what they will do is they will make bonds. So covalent bonding, which is what we talked about before in the simulation, covalent bonding is sharing a pair of electrons, a pair of, also, let's introduce this because I ran out of room, plus at some point we should learn this, a pair of E minus, and that means electron. This is a shorthand for electron. So covalent bonding is sharing a pair of electrons. I hope you made my video big because this is one of those, I don't know how to tell you without telling you days. And of course there are videos all over YouTube on this, but I think we're going to have to do it where I tell you and then you also hear it from someone else in that order, just as a practical thing. And you know what? I should do this, sharing a pair of valence, because I should make that point. Oops, valence electrons. Sharing a pair of valence electrons, and that's going to matter. So I'm going to say, oops, I should have said that in the first place. So that pretty much is the setup for this. And at that point, we can kind of get going. So I will try to go slow at first. We have an H atom and we have an F atom. And the point is, when I say this, I mean that they're going to bond. How are they going to bond? They're going to do covalent bonding. They're going to share a pair or 2 or 3 pairs or something of electrons. So how many valence electrons does hydrogen have? And we said this before, so this is probably the 3rd or 4th time you've heard this, but this is the 1 valence column. Do you need to make a note on your periodic table? 1 valence, 2 valence, except the rest of these metals aren't going to come up in these problems, but 1, pretty much you only need to talk about the hydrogen. 1 outer shell electron, this technically is 2, but they won't come up, so if you skip that, it won't matter, honestly. We'll skip over this part, and 3, 4, 5, 6, 7, and this column is 8, but it won't matter because they won't come up. So, I mean, you can write 8, but I don't think it might not even be useful information. So 3, 4, 5, 6, 7 valence electrons. I know some people will want to write that in. Does anybody need to hear that again? This whole thing does get a little complicated, and I hope I've given the impression that I like questions. Excuse me, I have a question should be something you should be willing to say. I'm going to say, thank you for asking. I'm not going to act like, shut up, kid, I'm talking here, right? So if you're confused, speak up. All right, how many valence electrons does hydrogen have? 1. So we might put 1, and we just draw a dot. And fluorine has, we said, 7. Now, in general, these operate in pairs. So usually what we do is we try to make them in pairs. It's not super duper important right now, but there's 7. except fluorine wants to have 8 electrons and hydrogen wants to have 2. And the way they can solve this is by covalent bonding. They can share a pair. And look, they each have a 1 single electron, because electrons like to be in pairs. So these electrons are a little bit unhappy in a certain sense. So what we could do, and I promise to keep the erasing down. I'm just doing it this way this one time, pretty much. We could erase these. Whoops, I erased that one by accident. And we could put them in here. And we didn't cheat. This is still the same number. This is still 8 total. Sorry. You know what? I was wrong before, wasn't I? Excuse me. I put the wrong number of valence on fluorine. I put 2, 4. I put 5. There are 7. Please correct it. I was wrong. I am pointing out my mistake in case you were copying me. Also, I would think that somebody would say, what? That was 5 and you said 7. No one said anything. And I am gonna make dumb mistakes if I keep, while I talk, I know it's gonna happen. It's been happening forever. So if you think I'm wrong, and it's pretty obvious, you should, tell me. So fluorine has 2, 4, 6, and 7. Hydrogen has 1, and what they're gonna do is they're gonna sort of combine forces here, and they're gonna share this pair, and this pair is gonna be a bond. You don't have to circle it, but you can. And usually what we do is we write it like this. You don't have to write them twice. I'm just doing it this one time. We just write a dash. And that means 2 shared pairs. Do you need to take a note? That dash is, 2 shared electrons. It's 1 shared pair. That dash is 1 shared pair. It is a bond. That dash is a bond, and there are 2 electrons in it. And then fluorine has 6 more, doesn't it? Now there's one more thing, and then I'll pause for questions again. This bond counts for both sides. It's like a Venn diagram. So hydrogen says, and that's my bond, and I have 2 valence electrons, and I'm happy because hydrogen is looking for 2 electrons. And fluorine says, that's my bond, and I'm happy because I have 2, 4, 6, 8 electrons. So the bond counts both ways, both directions, for both atoms involved. And these are not bonded.
Up a little.
Do what?
So that can you move your paper up a little so that I can write the rule or whatever?
You mean down.
Oh yeah, right.
Okay, good point. And when I pin my video, I often can't see who's talking. Niche, I guess. Good point. If you get that, you're like halfway done, honestly. Okay, so please speak up now if you have a question or that makes me think of, or I was writing this thing and I missed what you said. Well, we can do NH3. Okay, also, maybe note to self, when you have that 1 atom, because there's invisible 1 here, this one, the one with just 1, is going to go in the middle, and the others will be arrayed around the outside. So we'll do something like H, H, H. I don't want to argue about the angle right now. We'll get to the angles and all that stuff later, and there's a chart so that you don't have to memorize it all. But I'm just saying they go around, and it looks better if they're evenly spaced. Probably, at least for now. So, how many valence electrons does hydrogen have? 1. So, how about, to save the erasing, we put the 1 toward the middle, because I bet we have to use those for the bonding. So, let's just put them in the middle to start with, between the atoms. And how many valence does nitrogen have? And we said this is the column 5 valence set, so nitrogen has 5. So now this is one of those ones where if you plan ahead, you can really save your eraser. This whole thing, I mean. How many electrons does each bond need? 2. So how many more do I need here? I need 1 more and then that can be a bond. I need one more here, and that can be a bond. I need one more here, and that can be a bond. And yet, I'm not done. And somebody out there is thinking, wait a minute, he said this, but he did that, and you're right. What am I missing? What, anybody gonna speak up?
What about so the the three bonds, does
Yeah.
that count as like nitrogens, or is it only are we only counting 3 of the electrons for nitrogen, and then are we going to draw the other 2?
That's it, thank you. Thank you, and who's speaking?
Jessica.
Jessica, thank you. Oh, I see, yeah. I was looking at the person at the top, but I hadn't scrolled up. Thank you, Jessica, that's exactly what I meant. Yes, 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 yes. I said there are 5 valence for nitrogen, and yet I only used 3. There are 2 more. You got it, Jessica. There's your gold star for the day. And so somewhere on the N, let's not argue about where. Honestly, for now, let's just put them somewhere. I'll choose over here. There is another unshared cloud on nitrogen, or some people just put 2 dots. Let's not argue about that either. Some people draw a little balloon, and some people just put 2 dots. Make a choice. It's actually more useful if we start off with the balloon shape, probably because of where we're going, like next week. And now nitrogen has 5 valence. So how many does this hydrogen have? It views the bond as it's mine. I have 2. And this one says I have 2. And this one says I have 2. But the nitrogen says I have the bonds and my unshared pairs. So I have 2, 4, 6, 8. Now, the circles I just drew are not part of the official answer. I'm just trying to be helpful. If you can do it in your mind, even better. These circles here are just my giving an illustration. If you can start skipping them, great. If you don't want to skip them for now, okay. So, is there something I should run back on this? Well, C with 4 H's on it. What's the valence on H? 1. We just said that twice. What's the valence on C? This is column 1, 2, 3, 4. It's 4 valence. So again, the single atom goes in the middle and the rest are around. So maybe we should put it about like that. It's not super important, but it looks better anyway. Plus you got to have some room to write. So the H's all have.
I'm confused.
Well, go ahead.
How did you get the valence electrons for C?
The valence for H?
For C.
We said that the valence goes 1, 2, skip over the middle, 3, 4, 5, 6, 7, 8.
Oh, okay.
And in fact, that's the whole reason why this table is laid out this way. If you put like weird periodic table into Google, you can find people making circles and even, God help me, like triangles or something out of the periodic table. I have never seen one of those weirdos on a wall. Everybody prints it like this so that you can do exactly what I just said.
Okay.
That's why it's this shape, literally. Okay, so carbon has 4, hydrogen has 1. It's going to save our erasers if we just go ahead and put this 1 for the hydrogens in the middle so that we can bond with them, because I bet that's what we got to do. And then I don't have to move them. And carbon has 4. Well, look how many bonds I got to make. 4, and it has 4? Well, that sounds perfect to me. I'll put 1 here, and look, that's a bond. 2, that's a bond. 3, that's a bond. 4, that's a bond. And I think I'm done. And if you want to, you can draw these out, but you need to sort of visualize this to make sure you're right. This H says, I own this bond, I own this bond, and I own this bond, and I own this bond. But the carbon views it as I own them also. And so the carbon views itself as having 8 valence electrons now, which goes back to this. Is there something I should go over on that one? You know what I think we should do? Take a minute and just try number 4. I won't know if you get it wrong. You don't have to tell me. But how do we learn? By trying. See if you can knock out, you know, it's okay to be wrong. It's not a quiz. Oh my gosh, not you guys. Me. Hold on. Keep going. Okay, it's not a quiz, so who has a question? Probably somebody's thinking, wait, what about the thing? Or how do you do that part? Or something. Well, then I'll start N in the middle because it's the one that's a single, and F probably kind of around the edges like that, I would guess. N is in my 5 valence column. F is in my 7. So if I do this, 2, 4, 6, and I put that single one toward the end, that probably saves me erasing because the single ones usually get used for bonding. So I'm going to do 2, 4, 6, and the 7th one toward the middle. 4, 6, 7, 6, and the 7th one toward the middle. And then we got to make some bonds, and nitrogen comes in as a 5 valence. And so it's going to have to make up the difference in the bonds. It needs to contribute 1, that's a bond, 2, that's a bond, 3, that's a bond. And like Jessica spotted before, that leaves 2 that I didn't use. Where did they go? Honestly, somewhere on the N. And the reason that it doesn't really super matter is because electrons are not fixed in one spot. If any electrons on the N are doing big laps at like light speed, and sometimes in some very funky shapes. So if you put them on top, that's not right. To the right isn't correct. To the left isn't correct because they're really going anyway. So pick a spot. In fact, somebody speak up. Where do I put them? Just to show I don't care, I'll let some kid tell me. Where do I put them?
Left.
Left, so they go on the left, sure, and they're in a little balloon cloud maybe.
So I have a question for the balloon cloud thing. Are we
Hmm.
putting the balloon cloud on the F too? On the Fs?
Oh, to be picky. Okay, you know it's a really good question. You might get another little gold star here. To be picky, yes, these are clouds. It seems like extra writing, and it's not actually all that helpful. I mean, yes, to be extra picky, you could do this, and people would say, "Oh, well, yeah, you could do that."
I
So
have
we
a
can do
question.
clouds instead of those dots?
We need to see the number of dots.
I have a
In fact-
question.
Yeah.
Does there need to be a certain amount of dots?
Can I deal with the dots question just a moment? Yes, because the fluorine came in with the 2, 4, 6, and 7, right? Okay, here, you know what? And please, the other boy who was speaking, I want to get to your question. Hold on a moment. Here's an alternative, faster way. Now that we've done this, another way that the AP kids do it on the test is like this. They would end up with this. F, 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 right? And then they would just put dashes for every 2. Here's 2, another 2, another 2. 2, 4, 6, and the 7th one was in here. 2, 4, 6, 2, 4, 6. And this is the same thing. Oh, sorry. And the one on N, like that. Except, you know what? That's not as useful. I'm trying to be helpful here. I'm not saying that's wrong, but it would help you on the center one if you put the cloud and the 2 dots because of where we're going next week. So 2, 4, 6, 7. Remember the 7th one here? 2, 4, 6, 7. 2, 4, 6, 7. And then nitrogen contributed 1 and a second one and a third one. And here's the other 2 to make 5. Okay, I didn't see who was speaking, but whoever was asking about the dots, does that work for you?
Yeah.
Okay, who is next? There were 2 people speaking. Maybe you had the same question, basically? I don't know. I thought there was another question. Also, was it Jessica who's asking about the bubbles on the F?
Yeah.
Does that work for you? You can, but honestly, no one does on these outside ones because it doesn't really help in the future. So I've never done it.
Okay. And there can only be 2 bubbles in or 2 dots in the bubble.
Yes, they really do. The electrons travel in pairs for deep, dark reasons that I was never really told.
Okay.
Swaney, can you do number 8?
Yeah. Unfortunately, in this class, nature is complicated enough that sometimes, even right now, we've already hit a point where I go, if some kid says, but why? I honestly am stuck with either take some really deep math classes about wave functions, or just tell yourself that's the way God made it or something. I don't know. I don't know why they're in pairs any more than that's what everybody says. All the extra educated people tell me that, so, that's the way it is. Okay, 8. Okay, all right. And just in a nice way, who is that? Who's asking? Questions are good.
Oh, Davion.
Okay, this is it. Okay, you asked for the curveball, buddy, so here we go. You know what? Can I do 7 and then 8, though? Because I think it works better.
Go ahead.
Okay, O and O. So what's the valence on O? 6. So, okay, let me say this before we get started. Some people have had this topic in 8th grade, and I'm trying to say this in a nice way and so forth. I do know what I'm doing, I promise. And if you had that teacher who did it in 8th grade or something, and they did it slightly different, just keep following along and you'll see that I'm getting the same answer. Just sometimes I've had a kid say, no, that's not how it goes. You put them here and then you move them and so forth, because the teacher was kind of maybe dumbing it down for middle school, or maybe they just didn't know very much themselves. So just follow along. So oxygen has 6, right? 2, 4, 6. We said a dash is 2, right? 2, 4, 6. Except there has to be a bond. You can't leave this blank. This is a super wrong answer because this doesn't even have one bond. So this is not a molecule yet. So we got to bond it somehow. So let's borrow a pair from somewhere. Honestly, I don't care. Here maybe, and put it in the middle. But I still have the same number of electrons, don't I? Except this next point is why this is a curveball. So if you've been staring into space or you walked away, hey, come back. Go ahead.
Doesn't the left one have too many electrons? Because
No.
now it has.
No, the left one has 8. Remember, they both view the bond as their own, right? So mentally, or maybe with your pencil, yeah, you do this. If you can do it in your mind, that's fine. And we do this, right? So the left one has 2, 4, 6, 8, and it's fine. The problem is with the right one. The right one diagrams as 2, 4, 6.
How do you know, like for number 6, how do you know that there's 6 dots?
6 dots. Oh,
The dots going around the F.
oh. Okay, I'm going to do this real quick. F, F. Fluorine has 7 valence, 2, 4, 6, 7, 2, 4, 6, 7. Oh, look, let's just share these.
What?
And then,
Wait. F. That's on the periodic table? Is that what I'm missing?
what?
That's what I'm missing. Okay. Wait, what? I'm not. Never mind. Go ahead.
Okay, so the problem here on 7 is the right one at the moment is not correct because it has 2, 4, 6, and it is oxygen is not going to stand for it. It is going to get grabby and greedy, and it's going to grab something. So it's going to grab a pair off the other one and put it into the bond. I don't care which pair it is. Remember, these are not really up, down, and sideways anyway. Really, all these are just going all over the place. So pick a pair. No one cares. I guess I'll just pick the top because it looks better, but it doesn't actually matter. And I'll say, and then this one grabs that top pair and puts it in here. And now they both Venn diagram as having 8 valence electrons because they both view the bonds as belonging to themselves. Okay, again, I missed who was asking about 6. Did you get 6 figured out?
No, I don't get it all. I don't even know where those dots are coming from.
Okay, I think it'd be easier if you pay attention to what I was doing though. Okay, I'm going to back up. Oh, first of all, before I do that, is there something I should repeat about 7? I can do it again. In fact, I can start over. Anybody need just, oh my gosh, can you start over from the beginning?
No, you're good. Move on.
Here, you want me to start over on 6 though? F and F, right?
Yep.
F has 7 valence. Do you know what I mean? You can say no.
Wait, what?
F is in the I have 7 valence electrons column. Did you jot that down? Do you know what I mean?
No.
Oh, there's our problem, buddy. I said this table is this funky shape so that you can say 1 outer shell electron valence, 2, skip the middle, 3, 4, 5, 6, 7, 8 valence electrons.
Okay, I get that. So
Okay.
there's 7.
Yeah. So it brings in 7 valence electrons, right? And then somebody says, I know, but what about the middle ones? He never talks about the middle ones. They won't do anything, so there's no point in discussing them. It's like trying to find the traction of the asphalt in the middle of the road, under the surface. It doesn't matter. No one cares what the traction of the the asphalt is 1 inch deep. It doesn't come up, right? So how many do they have? 2, 4, 6, and the single ones will be better if you put them in the middle because I bet we bond with them. It's probably less erasing. I mean, you don't have to, but I'm just trying to save your eraser. 2, 4, 6, and 7. Every bond, covalent bonding, is sharing a pair of valence electrons.
I
Let's
get
share
that.
a pair. And then we generally illustrate this. Everybody seems to want to illustrate this with a dash. And every dash was 2, so I did not cheat. That is still 2. And are we done? If you mentally Venn diagram these, do both atoms come up as 8 valence electrons? Yes.
I have a question about number 5. For
Yeah.
SI, does that, because SI is in the like second row for,
Well, 4th.
yeah, 4th row, but it's
Column.
under carb. Does that change anything, or is it still for valence?
It's 4.
electrons?
It's 4.
Okay.
Okay. Okay. So somebody asked for 8. Oh, sorry. Did we get 6 solved? Was that O'Davian?
Yes, and I
Okay.
asked for 8.
Okay. Triple checking. We're good for 6?
Mm-hmm.
Okay. So here's the extra curveball, N2. How many valence does N have? 3, 4, 5. So this one's going to need some eraser, by the way, probably. 2, 4, and the single ones are probably toward the middle, I said, right? Just to save your eraser a little bit. So that's 5 each. And then the ones in the middle, oh, look, we don't have to erase. We can just make a bond out of that. Great.
Okay,
That
now
go ahead.
go ahead.
Go ahead.
Okay, so now on what you just showed right there is different from the answer key. So on the answer key, they put 3
I know.
lines in the middle.
Yes. Right, because we're not done. We're not done.
Oh.
That's a good point. I'm not yelling at you. I'm just saying you're right. Good point. This is not the answer. Because let's double check. Are we done?
No, it doesn't.
Mentally, right, mentally Venn diagram this, and everybody thinks they own the bond in the middle, and they both come up as having 6 valence electrons. Nobody's happy. Nobody's going to sit there and take it. Not nitrogen isn't going to sit there. Okay, just to say this once, boron is so weak that it has to sit there sometimes with 6 a lot, well, basically all the time. But carbon, nitrogen, oxygen, everybody else is going to get grabby. You give them 6 and they're going to say, nuh-uh, that's not happening. So pick the left or the right. It doesn't matter. I guess I'll start left. This is unhappy. It's going to get grabby. It's going to grab one of these 2 pairs. Remember, it doesn't matter which one because they're not really in one spot anyway. I guess I'll pick this one for no special reason. And it's going to say, nope, I want to bond with that. The left one says, I now have 8 valence electrons, just like I wanted. The right one is still unhappy, so it gets grabby. Grab a pair, any pair, and it says, nope, you're bonding that with me, pal. And now everybody Venn diagrams as having 8 valence electrons. Octavian, does that work for you? You can say no.
Yes, it did.
Okay, Questions are good.
Can you do 18, 19, or 20?
Yeah. Okay, so let me think. In fact, I need to peek the answers because I want to not jump too far ahead. Is 18 to, okay, 18 is not a super jump. It's only a nice jump, not a big jump. So we said the single one goes in the middle. The O's go around the outside. I suppose this would probably look best if they went evenly around the outside like that. Okay, here's the thing though, and I would make a note somewhere. Now, you did kind of know this way back from the atomic structure quiz, but when something is -3, it has 3 extra electrons. I would write that down. That -3 means it has 3 extra electrons somewhere in here. And another little note, it's usually easier if you just save them and put them where you need them later. Like you put them on the center. Often you put them on the center. So, how many valence does oxygen have? 3, 4, 5, 6. So, using the dash method, which is easier, let's go 2, 4, 6. There. How many valence does phosphorus have? It's in the 5 valence column. Now, hold on though. We get 3 extras. So let's view it as phosphorus doesn't have 5 this time. It has 8 because I get 3 freebies. And look how many bonds I need. 4. How many electrons is that going to take? Valence electron. 8. How many is phosphorus throwing in? Because it has 3 extras, it's throwing in 8. Well, that's super convenient. 2, 4, 6, 8. And I have everything bonded. And then, remember, as Damien and Jessica and some people were pointing out, up here, you have to triple check, mentally at least, draw these circles. Is this oxygen happy? Does it have 8 valence electrons? Yes, 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 yes. Does the phosphorus have 8? And it's going to say 2, 4, 6, 8. Everybody is satisfied on this. Everything has 8 valence electrons in its own view. There's just one more thing. If you're going to have a minus, you need to do brackets and say, I know there are extra electrons in here. I didn't make a mistake. They really are. I'm not just making stuff up. That's how we do it, if it's minus or plus. Should I go back on part of that for someone?
I'm confused on number 9.
Okay. Just a moment. Call again on 18. Anybody? Okay, on number 9, oh, what you would get in the what you do is you make a string of the carbons. I know 2 carbons is like the shortest string possible, right? But you make a string of them, and then stick the hydrogens on as evenly as possible. So 6 hydrogens on 2 carbons goes 3 and 3. Hydrogen has 1 valence. Carbon has 4. So let's put 1, 1, 1, 1, 1, 1. And carbon brings in 4. And look what we need. How many bonds does this carbon need? 1, 2, 3, 4, huh? So if I put 1 here, I can make that a bond. Put 1 here, I can make that a bond. 1 here makes that a bond, and I can put 1 here. I can put, for this carbon, I can put 1 here and make a bond, 1 here and make a bond, 1 here and make a bond, and then it has 1 more. And now I have 2 between the carbons, and that can be a bond. And then we mentally Venn diagram everything. And is everybody happy? And remember, when you do this mentally, that hydrogen is happy because it only wanted 2 in the first place. And the carbons feel like this. I have 8. And this one says, I also have 8. I think that was Jessica. Does that work for you?
Yeah, it does.
Okay. Good. Oh, you know what? I see an error on my dumb solutions. 23 should say or like, you see the note on 22? It says res structure. That means resonance structure. On 23, we should add this. And I'm going to write out the whole thing. I know I didn't teach this part yet. Resonance structure. Oh, here I thought I scanned only the ones with all the correct answers. This is an octet violation. I'm going to have to print this out and make a new set of solutions, darn it. I guess. Okay, so there's one more thing to point out, and then you can either try them or you can go watch the videos or something. There's one more thing. Sometimes the double bonds are not just in one place. It's probably easier if we do an illustration like 19. I take the single one, chlorine, I put it in the middle. And I put the O's around the outside. I'm being quiet because I'm thinking, hold on. You know, I think 19 is wrong. Sorry, what? You know what? I think my answer for 19 is wrong. I'm going to have to repost these solutions. But if we continue with 19, oxygen has 6 valence. Chlorine has 7 valence, but I get an extra one. See the minus sign? You know what? My dumb answer for 19 is wrong. I can put them anywhere I need them. I'll use 2 of them for a bond here, 2 for a bond here, 2 for a bond here, and then I've used 6 out of the 8 that chlorine has, if I remember that extra one. So that means I have 2 extras, and remember that center cloud? idea. And if it's minus or plus, we put brackets and a charge. I'm going to have to go over these answers. I'm sorry. Should I repeat something on 19? Okay, if you've been off on your own, and I know some people are like, I got this, watch, I'm gonna match these answers. Right, if you ran ahead, that's fine. Can you come back now though? Because 20 has a new idea. Carbon goes in the middle and oxygens go around the outside. The single one goes in the middle, right? Carbon has 4 valence, oxygen has 6. So it's easier if you start around the outside. So 2, 4, 6 for oxygen. Now, carbon has 4, but we get 2 extra electrons. So carbon kind of has 6, and we'll use them up here to make bonds. And here's the extra new bit. Hey, listen to this. If you do the mental Venn diagram on carbon, it feels like it has only 6 valence electrons. And it's not gonna stand for it. It's not gonna sit there and take it. It's gonna get grabby. But here's my point. Here's the point, and I end up having to repeat this like 7 times, so can we listen? The choices for it to get grabby are all identical. This one is in exactly the same position, so to speak, the same situation as this one and that one. So when it needs to get grabby, but all the choices are equal, it chooses equally is what it turns out. And what we get is something weird, I admit, but it has been essentially proven that this happens. What it gets is sort of a 1/3 double bond in all directions. So we get a third of a double bond here, and a third of one here, and a third of a double bond here. And I wish I could explain that a little bit better, but I haven't actually seen anybody explain it better than that I've seen. How can you have part of a double? I know. But various experiments have pretty much proven that is what's going on. So let's pick one of these to steal from and make a double bond. And just to prove I don't care, let's not pick the bottom one, because in the answers I pick the bottom one. Let's pick this one just because. Oh, you can pick the bottom one, I don't care. I'm just proving it doesn't have to be the bottom one. And I make a double bond because I move to this pair here into a bond. But really, this situation happened partially all 3 spots. This is not a double bond here. It's really happening partly here and here and here. They used to think that it went double here, then double here, then double here, then double there, then double here, 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 here. And it was flipping and sort of bouncing or resonating, and that's why it got called a resonance structure. No one believes that anymore, but the name is sticking with us. So this is a resonance structure because it's partial double bonds throughout. Now, also, in case you think that's super annoying, your actual response should be thank you, because in college, I had to write it all out 3 times. I had to write it bonded double here, and then write it all over again, double bond here, and write it all over again, and double bonded here. So this is my I'm being nice to you version. Just tell me, yeah, I know it's really only partials by writing this, or even, you know, on the solutions I put that, because I'm tired of writing it too. Fine. This says I know one of these. I know it's really partially double bonded in all three spots. And then remember the charges get brackets and a charge outside. So that is weird, I admit. I should probably answer something about that. Okay, there's only like one and a half more things to say. And I think I'll say your brain is probably full. And if I do 24, and I'm going to do it a little bit faster, because my point is the end. I want to make a point about the end answer and not about how to get it, because how you get it is kind of normal. But it has what, 6 Fs? Yikes, 6, I mean. So if I put 6 Fs, whoop, okay. And then they all have 7 valence electrons, 2, 4, 6, and then one of them was in here, 2, 4, 6, and one of them was in here. And that repeats. My point is, I'm going to skip the explanation of how we got here because there's nothing new about how we got here. Everybody, we Venn diagram it and we say, oh, this one feels like it has 8 valence, and this, but here's the point. The sulfur Venn diagrams as having 2, 4, 6, 8, 10, 12. And remember when I said the octet rule wasn't really super a rule? It wasn't actually a rule. It just got that name. Well, it gets broken sometimes. And here's one of the examples. So this is an octet violation. Because sulfur diagrams as having not 8 valence electrons. And so at least in my classes, I don't remember if I had to do that in college. I probably did. I don't remember. But I've been having kids write down the words octet violation so that they can say, yeah, I know it's 12. I know. But seriously, it's 12. I know it's breaking the supposed rule, but I'm not kidding. That's the way it is. I recognize that that's breaking the rule, but too bad. That's the way it is. It's not really a rule. Should I repeat about an octet violation for somebody, and or why it is, or when you know, or something? So you might jot down an octet violation is when one atom has more than 8, more or less, more or fewer than 8 electrons, valence electrons in the final answer. And I only have one more, and I'm probably going to say, you know, try these or discuss with me or go watch the videos or something, because I know this is the 3rd class and this is a big info dump today. There's one more little thing I would probably point out, which is this one. Borons in the middle and fluorines are around the edges. And boron has 3 valence electrons and fluorine has 7. So if we put the 7 on fluorines, you might want to do this, 2, 4, 6, and the 7th one toward the middle. 6 and 7th toward the middle, 2, 4, 6, and 7th one toward the middle. And I'll wait a moment. But but boron only has 3 valence. And so all we can do is 1, and that can be a bond, 2, and that can be a bond, and 3, and that can be a bond, right, in the middle. And here's my point. So far, we didn't do anything else except I know what somebody's thinking. The last time it ended up with 6, he said, they're not going to do that. They're going to get grabby. And I ended up with this weirdo thing about double bonds and all, right, kind of a nightmare. But here's my last point. Boron is too weak to fix this problem. It's going to sit there and take it, and that's the answer. We're done, except for octet violation. But it only has 6. I know, it breaks the rule. My little phrase, in case this helps, is boron gets bullied. It sits there and takes it and has 6. It can't fix it. Boron gets bullied and it just sits there and takes it and has 6 valence. However, that is an octet violation. At that point, I'm going to say, if your brain is full, then just go watch the videos and take some notes. If you're saying, if I had to solve another one of these right now, I think I'm going to like snap a neuron in my brain. Okay, then just like go watch the other videos, and you don't have to figure them out. You can just take some notes with the other part of the assignment. Or for all the people who are like, okay, I think I got this. What should I do? Should I do another example for somebody? Somebody want to make a request or something?
I know it was a while ago, but how do you do 10? Because it has.
Oh, okay. So, all right. So we put the C's in a string, I said, right?
Yeah.
And divide up the H's as equally as possible. Well, obviously, it's only 1 each, right? 1 H on each C.
Mm-hmm.
Okay. So how many valence do we have? 1 on the H's and 4 on the C's, right?
Yeah.
So how about, well, let's see. How about we put 1, that's a bond, 2, 3, 4 or something? 1, 2, 3, 4. Is that fair? Do you know what I mean? You can say no.
I thought you had to have both of the extra ones together, or.
I'm just not done. Oh, okay. You want it? Well, here. Well, I wasn't done. Okay. You know what? Fine. You want to do this? That's fine. In fact, good. Good point. There. Is that what you meant?
Yeah.
Okay, fine. So then these two can make a bond, these two can make a bond, and these two can make a bond.
Mm-hmm.
Except if you Venn diagram the carbons, nobody's happy
Yeah.
because they both come up as 6, right?
Yeah.
And last time we said, and they both come up with 6, they both borrowed, excuse me, this was it, right? They both diagrammed a 6, they both borrowed, and we ended up with a triple. So guess what?
We're going to do that again?
Yep. They're both going to get grabby because if the left one gets grabby, it says, look, 2, 4, 6, 8, right? But the right one is still unhappy. 2, 4, 6, right?
Mm-hmm.
If you stop here, the right one kind of borrowed its own money, which doesn't count. You can't borrow your own money. You don't get anywhere, right? So moving this one into the middle doesn't fix the problem for the one on the right. Do you see what I'm saying? No? If I stop here, this is not correct, but if I stop here, I get 2, 4, 6, 8 on the left and 2, 4, 6 on the right carbon.
Mm-hmm.
So the right carbon did not get solved by this movement.
Yeah.
Okay, because that's what I mean. It kind of borrowed its own money.
Okay.
You can't just move your own money in your own accounts and get richer, right? You have to borrow other people's money. Well, that's what the left one did. It borrowed other people's money. So now the right carbon has to borrow other people's money and borrow the one from the left and put them in the middle.
Okay. Now they're both happy.
And now they both have 8.
Mr. Sweeney.
Yeah.
Can you do 25? I mean 35, not 25.
Oh, I think that was one where we got to kind of peek at the answer for a moment. The question, sorry, not the question. The clue is that the H goes on one of the O's. So the N goes in the middle and the O's go around.
Mm-hmm.
honestly, I haven't done this in so long, I'm having to actually think. Pick an O, it doesn't matter. It's on one of the H is on one of the O's. There's no upside or downside to a molecule, right? So what's up? I don't know. So, which one is the H on? I don't know. Pick one. In fact, you pick one.
The top right, I guess.
Top right. Okay. So the H brings in 1. The oxygens bring in 6. 2, 4. 5 make a bond 6. 2, 4, 6. 2, 4, 6. And then the nitrogen brings in 5, right?
Yeah.
So look, let's throw 2 of them in here, and that's a bond. 2 more, and that's a bond. That's 4 out of the 5 I had still coming to me. I have 1 more coming to me, and look what I have, a single here. So if I throw in the 5th one here, that matches up, and I can make a bond.
Now nitrogen only has 6, right?
Thank you. Yes, yes, yes. Someone has been paying attention. Good job. Here's your little gold star for the day. Yes. This is not going to sit there and take it. I said only boron gets bullied like that, right?
Mm-hmm.
Nitrogen is not going to sit there and take it. It's going to get grabby, but look at these are easier to grab from than this one, because this one has some of its electrons occupied back out here, right? So these are easier to grab from, so it picks equally between the equal choices. So which one does it grab from? Both, in a sense. Not in a sense, actually. I shouldn't say in a sense, both. So we get half a double bond and half a double bond. And instead of having to write this out, the whole thing twice, like they made me do in college, which I found super annoying, let's just pick one of them and then write resonance structure at the bottom. So pick the top. For no good reason. Pick one of them, borrow a pair and put them in here. But really it's happening half a double bond each place. And to tell me, I know that. I know it's really half resonance structure.
Okay.
When the choices, when the center atom needs, or well, it's not always the center. When one of the atoms needs to get grabby and the choices are equal, it chooses equally and you get distributed double bonds called a resonance structure, which is a sort of dumb name now, but it's like people still say dial-a-phone even though there's no dial anymore. Probably 200 years from now, people will say dial-a-phone and people will only barely remember why that was even a phrase. Like little kids already don't know why it's dial-a-phone until they see a movie from the 70s or 80s or something. Okay, does that work for you on 35?
Yes, sir.
Okay. Somebody else have a request?
We can leave.
Yeah. Though do this, I'm gonna fix the solutions.
Solution for what questions?
Oh, I said that this needs to say octet violation and this needs to say resonance structure.
So do I need to make?
And then, oh, I said, what? Oh, I can post a correction. And that one, I was wrong. It is not a resonance structure, it's this. I can change them. I'll figure out something. Anyway, thank you for asking. Questions are good. Double checking is good. Somebody else have a question or a request?
31.
Okay. All right. So N is in the middle because it's the single atom and the H's are around the edges, I suppose.
Mhm.
Okay. The H's bring in 1 valence electron. And nitrogen brings in 3, 4, 5, but here's the trick. You're missing one. It's positive 1. How did it become positive 1? It lost an electron somewhere. Which one? I don't know, one of them. So let's
It'd
view
be
it this.
easier to take one from nitrogen. That way,
Yes,
one's not missed.
yes. So let's say nitrogen brings in 4 now. 1, that makes a bond. 2 makes a bond. 3 makes a bond. 4 makes a bond.
Okay.
In fact, that's why it lost one. Really, is because it didn't need it.
Yeah.
It was extra. And so there's always something around that wants one. So when it had an extra one, just kind of like it didn't fit in its billfold, right? Like I have an extra electron, please someone take it. You bet someone took it.
Mm-hmm.
And then we just say brackets +1.
Okay. And then we don't have to add anything, add a word under it or anything, right?
It's not a distributed double bond, is it? It's not a resonance structure,
No.
right? And
Yeah.
nitrogen diagrams as 2, 4, 6, 8, so it's not an octet violation.
Okay.
So that's it.
Okay. Thank you.
Yeah. Should I do another request for someone?
So do we finish this for homework
I think so, yeah.
and then turn it in by today?
You got the, got the solutions.
Okay.
And this is one of those classes that's going to have some homework. I mean, especially with 40% of the time gone, I'm already reducing the workload, by the way, because honestly, I would give out one of these, like when we got to this section, I'd give out one of these every day. I know most of the people didn't do them and their homework grades sucked, but it's not like they didn't really have the time exactly. Anyway, that's just me complaining. Should I do another sample for somebody? In fact, I probably need to make a rough coaching through this and put it up as a tutorial video so that when kids, maybe not you, when kids get a poor score on there, I can say, I not only coached it and gave the solutions and had them watch YouTube videos, I put up a tutorial video. Did you watch it? And then their parents can watch their face go, erp. Okay. I don't know. One more example, somebody maybe.
Could you do 13?
Okay, so HCN. And it's just like that. The H is not on the end, by the way. I know you say, how would I know that? Well, you wouldn't. I'm just telling you. So H brings in 1 valence, and carbon brings in 4, so like 1. Okay, remember when I said that some kids start arguing, no, you did it wrong. You can't move them like that. You know what just because, Jessica, I know you participate and pay attention and so forth, so I'm not yelling at you, I'm just telling you this. But some kids have argued back. That's not how my 8th grade teacher did it. You know what? Electrons are perfectly identical. There is no way to tell one from the other. It's like distinguishing BBs. So which one moved? No one knows. So let's just put them where we want them. So here's 1 from carbon, here's 2 from carbon, and 1 more? That's 4. How many does nitrogen get? 5. 2, 4, 5. I mean, I'm not super wrong. I mean, I'm fair so far. Agreed? I'm not done, but you agree that I'm not cheating?
Mr. Swinney.
Yeah.
So if you did that N one, right?
Yeah.
So So right now you have that little dot one at the bottom, right?
Yeah.
And the bond between C and N, isn't that already like one of the N's? So it's like 5 already.
Yeah, right. I'm sorry, what's the 5?
So like you know the bond between the C and the N, right? One of them's from carbon and one of them's
Oh.
from nitrogen, right?
Oh, no, what I did was that's the point I was making. We can put these anywhere we want and then fix it in a minute. So I was saying what I did this time is I said 1 from hydrogen, 1, 2, 3, 4 from carbon, and 1, 2, 3, 4, 5 from nitrogen.
Oh, I feel you.
Okay, it doesn't matter where you put them at first. And then you can move them because how do we know where they came from? That's what I mean about some of these 8th grade teachers. They coach it in this exact series of steps. You will do this, and then you will do that. And I've had some kids go, you're doing it wrong, because I paid attention in 8th grade and I know. But the reality is you don't know where they moved because you can't track them. So let's just put them down and then fix it. So I have 2 singles. Well, that is extremely unlikely. Plus, what does carbon diagram as? 2, 4, 5? No way. No way. So it's going to get grabby. Let's move these singles as a pair in as a bond. That's it. Oh, and this is a bond, right? So that's better, but it's not done because the carbon in the middle diagrams as a 6. And it's not going to take it because it's not boron. It's going to get grabby. And it can't get grabby from itself over here. It must get grabby from the N. So grab one of these pairs. It doesn't matter which one because they're not really in that exact spot anyway. Remember, again, they're really just doing around and around N. So pick a pair. I don't know. We'll pick the end one. And it gets grabby and does that. And now, I saw Jessica just saw 4 fingers.
N only has 5 then. That can't
no.
be right. Right? Oh wait. Right,
2, 4,
never
6,
mind.
8. Yeah. And carbon does this. And now everybody's happy. Actually, that's incredibly poisonous. That is really dangerous stuff. In fact, that's the classic one. Well, this is usually a gas, but the cyanide ion, this attached to something like potassium or something, is the classic suicide pill for spies. Like some of the Nazis were carrying this and killed themselves with this because it's so little that you can just keep it hidden in your clothes. One little tablet of that will put you down. I forget what it does to you medically, but the answer is bad stuff. It interferes with some sort of cellular process, and then when you're like your brain cellular processes stop, well, that's it. Anyway, I think it was Jessica who asked for that one. Is that working for you?
I wasn't the one that asked for number
Oh.
13.
Oh, was it Davian?
I asked for it.
Oh, Jalen?
Mhm.
Thank you. Okay, sorry. Anyway, does that work for you?
Yes.
Okay. All right, well, is anybody going to stay on here and ask for another one?
Just one more.
What?
Number 16.
Okay, so, right, this, notice, is a lot like that, except it's missing the H, right?
Yeah.
But it has one extra electron with a minus. So that solves the problem.
Oh,
That solves the difficulty.
I thought it was missing one because it was a minus.
I know, and every year I deal with that. But remember, electrons are negative, so -1 means you get an extra 1. So what you get is a 4 and a 5 and 1 extra, which is 10. which is 10, 2, 4, 6, 8, 10. So it's this without the H.
Okay, yeah, that
Oh,
makes
it's-
sense. I was trying to figure it out because it was like I thought it was missing one. No, it's an
Right.
extra one.
No, then it doesn't work, admittedly. Then
Yeah.
then it starts to be a real problem. And then brackets -1.
Okay. Right.
Okay, questions are good. Anybody else going to ask for another one? Okay, 3, 2, 1. I'm going to go then. Anybody got the last one? Okay,